See. I believe it should be recording. All righty. Well, welcome.
Okay. Thank you. Thank you, everyone, so much. Wow, what a cool opportunity to see where everybody's from. You all really are from all over the world, and we are somewhere in the middle of the world. We're last I checked, we're about 40 miles south of the equator, near Jarvis Island in the Central Pacific. So thank you for joining us, and thank you for letting us come together and meet you all. My name is Madison Dapsovich. I'm a communications lead here aboard EV Nautilus, and my job is to host interactions like this and to facilitate conversations around the science that we do on the ship. And when I'm not at sea, I am a science journalist, and I'm actually based in Western Montana in the US. And joining me today is Alec.
Yeah, hi everyone. My name's Alec Ramirez. I'm a recent graduate from UCSB's Department of Geography, and I'm a seafloor mapping intern here on the ship. And when I'm not on the ship, hopefully soon I'll be a grad student. So,
Yeah, Alec was just applying to grad programs earlier this cruise, so we're fingers crossed and hoping for the best as we await responses. So we're going to give you an introduction to the program, a bit about the technology and the tools that we use to facilitate our exploration. We'll talk a bit about our current expedition and what we're doing here and the objectives here. And then we'll go ahead and open it up to questions. So feel free to drop those in the chat as you go along, and we'll probably get to those towards the end just so we don't interrupt our flow. But to start off, let's go ahead and get you all acquainted with the ship. For those of you who maybe haven't joined a Nautilus expedition before remotely, here is drone footage of EV Nautilus. So EV, of course, stands for Exploration Vessel. And that's because we have two main components of our exploration program, one of which is conducting seafloor mapping, so characterizing and charting the seafloor in areas that don't have a whole lot of information and bathymetric information in particular. And secondarily, we do ROV or remote operated vehicle dives. And that enables us to get eyes on the seafloor and to visualize exactly what's going on, characterize the biological diversity of a given area, as well as collect samples to further our expedition and our scientific objectives. So Alec and I are actually sitting right here in this white box on the top of the ship. That's our control van. So during ROV operations, the control van really is our mission control. It's the heart of the exploration. And we have a team of about 12 people in there at any given time. But right now we're mapping. So we have a limited staff. We have 11 science team members on the ship in total. And that's because we don't need as many folks to man the mapping equipment. So Alec and the rest of the mapping team's lab is actually in the data lab, and that is below deck. We are able to come to you all through this satellite system here. It's our telepresence communication system, and that enables us to redirect it pointing to a satellite depending on our location in the ocean and where we are in the world. And then we can basically strategize the most efficient way to get connected via Zoom or Google Meets or through our live stream feeds. And then, of course, we have our aft deck back here. It's kind of off in the distance now. And so that aft deck is really where we launch and recover our ROVs, and where, again, a lot of the bulk of that ROV work happens. And again, it's a bit empty right now during this cruise, but let's go ahead and actually take you all to it live. What do you think, Alec?
yeah, that sounds
Okay,
good.
cool. So this is actually our aft deck right now. It's a little overcast today, which is abnormal. I feel like we've been lucking out with beautiful weather and smooth seas. But today it's looking a little cloudy. So here's our aft deck. That yellow crane on the far left is our banana crane. So we use that to launch and recover supplementary vehicles that we bring aboard the vessel. And those are often outfitted to us through the Ocean Exploration Cooperative Institute, which is an organization with a number of different actors, including Woods Hole Oceanographic Institute and NOAA, who really help to guide and facilitate a lot of our exploration. Then we have that A-frame on the back, and so that is how we launch and recover ROV Argus. And then we have that white crane on the far right, and that's how we launch and recover ROV Hercules. And we'll introduce you to both of those in just a minute. But the bow cam is looking kind of pretty. Like the sunrise is just coming up, so that's a look at where we're going. We're in our last full day of mapping in this area too, so we're actually heading back north starting tomorrow evening towards Honolulu, and we expect it to be about a 5-day transit. So this is a live look at our bow cam. And then, of course, we have our control van, which I mentioned earlier. And this is again empty right now because we don't have an ROV team on board, but that's a look at what it typically is filled with, the ROV pilots in that front row, scientists in the back row. And then, of course, that is the control van behind us. So we're in the studio in that area. So that's kind of an overview of the ship and really the exploration goals of EV Nautilus. Let's talk a bit about telepresence, and then we'll get to your question, Angela, about what mapping data that we're collecting and how that helps to further our understanding of these areas that we're exploring. So this is kind of a fun graphic. It's we use it with the kids a lot, but I do think it helps to show and visualize how we operate our ROVs in the water. So you saw that blue A-frame just a moment ago. We have a 7,000 meter fiber optic cable that connects ROV Hercules, and then ROV Hercules is able to collect data from the seafloor, stream it to a secondary ROV named Argus or Atalanta, and then that data is then fed to the ship. And from ship, as I mentioned, we're able to send that data to space. And then the data is collated at our facility at the Inner Space Center at the University of Rhode Island. And then, of course, sent to classrooms, communities, organizations all around the world. And we do, speak with members of many different countries and continents and states and schools and communities. And it's really an amazing way to facilitate, again, this conversation of science. And just as we're able to zoom in here, we're able to live stream our exploration in real time through nautiluslive.org, our website, and then through our YouTube channel as well. So we have viewers. We hosted an event yesterday that kind of mocked up what it's like to have an ROV dive occurring, and we had viewers from all over the world sending us questions, and then we can field those questions in real time, answer them, and it creates a really fun way of engaging with folks. And it also helps to support our Scientist Ashore program, which allows scientists who logistically can't be on the ship for a cruise to also remotely join in and help us with that exploration, which is a really important component of what we do, right? Is continuing that conversation both on and off the ship, and also both during and after expedition cruises. So just taking a look at ROV Hercules, we have it equipped with thrusters on the back. There's an HD camera on the front, two manipulator arms, and various other sampling mechanisms. So we have bio boxes, push core samples, sediment core samples, Niskin bottles, you name it, anything that we need to kind of collect items from the seafloor. And then, of course, we're diving at a depth of about 3,000 meters, give or take a couple hundred. And so it's very dark in these areas. There's an enormous amount of atmospheric pressure, of course, and we can have extreme temperature fluctuations, really hot or really cold. So both of our ROVs are equipped to withstand all of those environments, right? And then this is ROV Argus. So you saw this in that graphic just a moment ago. This is that secondary ROV. And Argus's main job is to, with that camera in the front, keep eyes on Hercules. So we're maintaining situational awareness through ROV Argus, making sure that ROV Hercules is operating in a safe manner, effective manner, and of course, we're leaving the ecosystem in, as pristine a state as when we entered it. Argus also takes a lot of the brunt from the ship movement. So, as Alec and I are kind of swaying back and forth, right? It's because we're on a moving vessel, and so Argus is meant to kind of mitigate that movement so that Hercules can operate smoothly on the seafloor. Okay, so that's a look at our ROV program. But before we dive with those ROVs, we have to collect maps, right? Just like we have road maps for a road trip. I don't know. I grew up with MapQuest. Did you? Did you already have like Google Maps?
We were still using paper maps.
Yeah. Okay. Cool. All right. All right. Didn't date us too far. Okay. So that's great. Sometimes when we talk to kids, they're like, "Wait a minute, you don't just use Google Maps." Um, so we create maps of the seafloor, and that tells us where we want to dive in. And Alec, as a seafloor mapping intern, you can probably tell us more about where we are in the world.
Yeah, so like Madison mentioned earlier, we did leave Hawaii about more than 3 weeks now. Yeah, just over 3 weeks ago from Oahu, and we've been transiting south for about 2.5 of those weeks. We did a little bit of supplementary mapping near the Big Island of Hawaii. Um, and yeah, so we transited south towards the equator, towards Jarvis, through Kingman Reef and Palmyra, and we've been working mostly in the northwest corner of that little section you see around Jarvis Island. That's the U.S.'s exclusive economic zone, so that's kind of a U.S. territory around the island of Jarvis. So we've been working there to kind of patch up some seamounts we knew were there but didn't have full data on, and we've been doing some additional exploration, just checking out some likely sites where some cool things could be. And we've been finding lots of seamounts and lots of very interesting bathymetry and geological formations. So it's been a very successful mission so far. And yeah, we're still collecting data.
Yeah, it's been a very successful mission. And to answer the question in the chat, what kind of data are we most interested in and what impact does it have? So with this mapping data in particular, I mentioned that it helps to inform our future ROV cruises. So next year we plan to come back with ROVs, and our science team is able to identify areas of interest based on these maps. So we'll be able to come back to those priority areas and then actually get eyes along the seafloor and see what's going on. And a part of that is to support, you just maybe saw on this map, the Pacific Remote Islands Marine National Monument. So that is proposed. It's a protected area, right? And it's been proposed to add Jarvis Island and that exclusive economic zone that Alec mentioned to PRIM, or the Pacific Remote Islands Marine National Monument. So while we don't advocate for or against inclusion in that conservation movement, our data does help inform the decision whether or not to include it. So in addition to this mapping information, being able to characterize the seafloor, we will then be able to better understand next year what biology lives in this area. We'll probably take a lot of geological samples to date the seamounts that we've looked at. And then again, just to really have a better picture of this area, right? Because you can't propose or exclude something, include or exclude something for protection if you don't really have an idea what's there. So that's a big part of what we're doing here. And then, Alec, when we're actually collecting that data, you've become an expert in this.
Yeah. So this is kind of an example of what the ship looks like while we're collecting the data. So specifically, we're calculate or taking sonar data. So we're sending and receiving signals from our sonar unit. It's a Kongsberg EM302. And we're sending these out constantly, hundreds per minute, down to the seafloor and calculating the two-way return speed. So basically, how long the sound takes to hit the seafloor and then how long it takes to come back. And with that information and really dense information, we do it, like I mentioned, hundreds of times a second. We can calculate these features where we're just basically averaging out all the different points and creating these surfaces. So what you're looking at now is one of those surfaces. That bright pink, that fuchsia color is kind of the deepest depth, and then as we go up in color ramp, that's the shallower depths. But yeah, this is a surface generated using that point cloud data collected by the sonar. And yeah, like Madison said, it's very important for informing our next dives. We don't want the ROVs to crash into the seafloor, so it is helpful in that way. But also, geologically, it's very interesting. Lots of research is being done about these, kind of formations and structures, and biology as well. We can kind of figure out where different biota might be living based on the kind of topography or the bathymetry. So like the slope or the rugosity of some different features.
Yeah, absolutely. And so let's just take a look at kind of what that data looks like before and after, and then I'll get to those other questions in the chat. I see. Thank you so much for sending them, and please continue to send them. So this is an image from our situation report. So it's an internal document. It's from December 4th, so it's about a little over a week old, but I think it really helps to highlight sort of what we're looking at here. So this is Google Earth data, and Google Earth uses what's called satellite altimetry data. And that creates these kind of like fluffy looking mounds along the seafloor, right? So it gives us an idea that there's probably a seamount, right? An underwater mountain in that area, or a seamount ridge line, right? So we have a more or less a mountain ridge. But we can't really see that detail and the nuances of what that feature looks like. Of course, we have our equator here, and teeny tiny little Jarvis Island here. And then this pink track line is actually what our ship has done up to that point. So now I looked at the map this morning and there's like a pink line all over this place, but it's harder to see these kind of fluffy mounts. So then when we actually take over with the multi-beam sonar system, we create these much more detailed maps, right? So you can see this is that satellite altimetry data. not quite as detailed. And then we have this really detailed multi-beam sonar data. And you can see we've been calling these marshmallow seamounts because they're kind of fluffy and cute. For some reason, we always name things after food. I don't know what that's about. But you can see, like, again, here's one of those, the satellite altimetry data, kind of fuzzy and hard to see. And then we have that track line where we can really begin to see the definition in detail. And so, for an example, like these are entire mountain systems. ROV Hercules is about the size of a postal service truck. And so if you think about it, like if you're driving a truck up a mountain, you can really only see, just a bit up that road and maybe not around the ravine. And of course, there's darker spots and lighter spots, and we're operating in complete darkness. So these maps really help us to determine where we should be diving. And they also help to tell us, based on current movement, areas that we might expect to find biological diversity. And so an example, I saw a question coming up, what's an example of, Grace, I think you asked it, what's an example of these sorts of areas with a lot of diversity? And this is one that I think of is really important. This was found in Papahanaumokuakea Marine National Monument. So this is already a protected area in the Western Hawaiian Island chains. It was that purple area you saw earlier on the map. And this you can see is a high density coral garden. So there are dozens, if not hundreds of different species of coral found here. We don't always see this, right? This is a kind of a special discovery to come into these areas. But you can see that this is probably worthy of being protected, right? It has an abundance of species. Deep sea coral grow incredibly slowly. So these are probably a few of these are probably a few hundred years old. I can show you in a minute a video of a coral we found that was probably around 1,000 years old. And so here's a gigantic sponge. Those two green dots are how we measure things in the deep sea. So that is 10 centimeters apart. So you can multiply it to do the math of how big that sponge is. It's also covered by basket stars. So these are their own individual species. And we see a lot of these dynamic relationships between coral and stars and echinoderms and squat lobsters and shrimp, right? Everything kind of lives together in these environments. And we've really this technology to explore the deep sea is still only a few decades old at this capacity, right? So we're really only beginning to understand what that looks like, what these interactions look like. And I see a question, are you noticing any form of behavior change in the aquatic life? At these depths, it's really hard to say because our baseline knowledge is still so new, right? So you're looking at another coral that's really massive, so probably a few hundred years old, covered in basket stars. Nobody's ever seen this coral before. So we don't really have a way to compare it to what it looked like maybe 50 years ago compared to today. And so, at these depths, it's just really hard to determine what changes are happening. And that's the same with climate change as well, right? We don't really know how those effects are impacting the deep ocean. There is a trickle down effect, right? So things that happen along the surface are probably impacting the deep sea, but we just don't have a really good understanding of what that looks like yet. So that's why it's so important to continue to characterize these areas. I'll show you a map real quickly, another map, because this is a mapping cruise. This is actually from 2020, so it's a couple of years old. This shows the lighter colors are the places of the world that we've mapped the deep sea at a high resolution, like you just saw. So not that satellite altimetry data, but that higher resolution. This was at 20%. So in 2023, 3 years later, we've added only 5% more. So there's a bit more, but not an enormous amount more. And so this really shows just how dark it is in the seafloor, right? Both like literally because there's no sunlight and figuratively because we don't have maps of it. We have a lot of places where there's a bunch of commerce, right, and transportation that have these lighter areas, right? Japan is quite bright, Australia, Europe, North America, parts of South America. But it's still, there's just so much ocean and there's so much to cover. We actually have better maps of Mars currently than we do our own ocean floors. So all of this mapping too is to contribute to an initiative called Seabed 2030, which is to map 100% of the seafloor at that high resolution in the next 6 years. So fingers crossed. Okay, cool. I want to just scroll up and make sure that we're getting to all of these questions because there's a lot of really great ones. Wow, Nigeria, India, cool. Okay, Angela, I think we got to you with mapping. What data are you collecting? And what things have you discovered so far? What, like with the mapping data in particular, Alec, what have you kind of discovered so far?
Um, well, specifically on this cruise, we found a lot of quite a few seamounts that we kind of underestimated the elevation or the depth with the satellite altimetry. So some good surprises there. Some strange little volcanic formations that we weren't expecting. So that was really cool.
Yeah, I love it when we see those huge differences in elevation from what we thought it was going to be based on that satellite data and then what it actually is. Like sometimes it's like 1,000 meters. I'm like, how is that even possible? So again, really important, especially when we're operating in these areas. So to get to the kind of moving down, so what things have you discovered so far, and what kind of data are you most interested in? Do you collect data about biological species? Yes. So this we saw earlier this year. This was a great example to kind of wrap in all of those questions. This is a sea pen, scientific name Solembalula. And we saw it in the, I believe it was in Papahanaumokuakea Marine National Monument as well, so in those Hawaiian waters. And it is really exciting because, at the very least, it's an expansion of range of the species. So we knew that they existed further north in colder waters. Now we've showcased that it's found in further south and warmer waters. So that's really cool. We have a hunch that it's an entirely new species altogether. That being said, we're not entirely sure because we are just doing the exploration here. So, for example, in this case, it's the only Solembalula of its kind in this area, so we did not collect it. That is one of our strict protocols. We have many criteria when it comes to collecting biological species in particular, one of which is there has to be proof of others of its kind in that area. So this one we left alone, but we did a lot of this zooming in and zooming out and sort of panning around the organism. And then this is our first observation of it. From here, we send this information to a sea pen expert who can better characterize whether it is indeed a new species or, at the very least, an expansion of range. So as exploration, we're really just getting eyes on the water. And then that science is continuing on ashore, right, in our scientist ashore program as well. So it can sometimes take, several years to definitively prove whether something is totally new to science or where it falls in that evolutionary tree. So this is really just the first step in understanding kind of what it looks like. So yes, sometimes we collect specimens, always we collect visuals. It really just depends on what sort of the circumstances in which we decide to collect specimens. Angela, Alec, this is a great question for you. Are you concerned about the sound waves hurting animals? Students are asking because some of the research they have read regarding sonar suggests that maybe it does have an influence on sea animals.
Well, it's tough. So personally, I believe no, and I think a lot of research is also backing that up now, that it doesn't have any significant effect on animals. If it does, it's not necessarily harm; it's more attraction. Specifically for some marine mammals that use sound as a communication medium or as an echolocation medium. But yeah, most of our research now suggests that it doesn't hurt them, and mostly it's because of the waveform of these sounds. So the frequency is so low, and also the signal is so fast, and really precise as well, that the odds of it hitting an animal are low, unless we're in like a very, very dense coral field. But then, an animal like coral might not be as affected as, an animal that's mobile or has other sensory organs that coral doesn't. And then, yeah, like the frequency is very low. The duration of the sound is very low. So overall, fairly unintrusive. If you were down there on the seafloor, you'd probably hardly notice it as we went past the 10 knots, just, really quick. So yeah, I don't think, well, actually, I'm fairly sure that it doesn't have a negative effect on the animals.
Yeah, definitely. So of course, the bigger concern with the sound waves are marine mammals that use echolocation. So they're basically using the same technology that we are to see, if you will, or hear around their surroundings. So a lot of the science does suggest that there isn't an issue. They can, like as Alex said, they're mobile, they can move away. And just to be on the extra safe side, when we do ramp up our multi-beam sonar systems, we do so very gradually. So we start at a very low, quiet sound and then eventually get a little bit louder. So that also enables the animals time to leave the area, if it is intrusive and bothers them. So long story short, marine mammals may very well hear it. It's likely that they do. We can sometimes hear it from different places in the ship, but it doesn't hurt us and it probably doesn't hurt them either. But we do have protocols in place as well to make sure that they're safe. Um, Really great question, and it's a really important area of study as well, right? We want to leave these areas in great shape. So let's see. Angela also wants to know, are we collecting DO, salinity, nitrate, pH, etc.? So with our mapping systems, we do what's called an XBT.
That's right.
And that collects certain data, right?
Yeah, so we're collecting temperature and salinity data 3 times a day to adjust our sound speed calculations. So just to make sure that the calculations we're doing regarding that two-way speed of the sound is accurate. So salinity and temperature are something we take into account in those calculations. So those are what we're collecting. As far as the other things, on XPT missions, absolutely we're collecting those, but they're not really mission critical for our mapping expedition. And also the time it would take to stop and kind of deploy those systems would really hamper our mapping. So just we have a probe we fire off the stern of the ship. It goes down, collects that data for about a 700-foot profile, just to get that top of that profile, and then we can interpolate it the rest of the way from there.
Yeah, and we do have systems on ROV Hercules when we're doing ROV dives as well to measure that sort of stuff. We collect water column samples as well, so then we bring that water back to the lab and we'll conduct eDNA analyses. So we're extracting DNA from the water column in order to determine what species were in it at a given time, and that also kind of helps us to create a biodiversity profile of the area that we're working in. So again, it really just depends on the expedition and sort of the goals and what we're trying to find about an area. And that, then we equip. And we can also kind of like, ROV Hercules is almost like a Lego. We can take certain things off and put certain things on. And it really depends on, again, the objectives of that expedition. Because I was on a cruise a month ago and we were testing a new camera system. So we took off most of our sampling mechanisms and then put on a bunch of different cameras. So we can plug and play a little bit depending on our goals. But wow, we are approaching the end of our 30 minutes. I feel like that went by super fast.
For sure.
I could keep, we could both keep going on and on because we're so passionate about this. But I did want to close by saying for all of the educators in the room, and if there are any college students, we have a science communication fellowship for educators, and we have an internship program for college students, which of course is what Alec is here with. And those applications are currently open through January 2nd. So if you're interested in coming aboard Nautilus and seeing the science firsthand, maybe joining myself or Alec in the future, please explore those opportunities. We would love to potentially have you here at some point. Thank you so much for letting us join in and tell you a little bit about our work. This is really, really special and important.
Thank you both so, so, so much. This has been such an amazing experience for our educators and our Globe community worldwide. It's really neat to see what y'all are collecting and doing, and also the opportunities that potentially some of our educators and students here today could take advantage of. So just thank you both so much. I know there's a lot of gratitude in the chat to you both and to the program. So just thank you again. And we wish you all the best with the continued mapping, and then of course the next mission and going and collecting samples and going deeper into those particular areas of interest. So thank you again. We really appreciate it.
All right. Yeah, we appreciate it too. Thank you, everyone.
Hey, thanks.
We'll see you next time.
Bye. Bye, everyone.
Bye.
Thank you.